Let's practice solving percent problems using proportions together. Essentially, there's going to be three different types of problems that we're going to solve for. One we're going to be solving for the part, one we're going to be solving for the base, and the other we're going to be solving for the percent. For questions 1 through 4, we're going to start by looking for a percent first. Alright, so for number 1, hopefully this makes sense because it says what percent here. And when it says what percent, we know what is going to be some unknown, so we're going to write x percent for a moment. The key word with the number 27 lets us know that the part is going to be 27, so I'm going to use the variable a to represent the part. And the key word of with that 75, or that of 75, lets us know that the base is going to be 75 here. As long as we can identify these three pieces of information, we can set up our general formula or our model here for what our percent proportion would look like. It's always going to be the part to the base ratio, and this is going to be equal to a percentage. Now, percentages are just ratios per 100, so x percent is essentially just x per 100. So this right here would be a great model to go ahead and use to solve these percent problems using proportions for all of these practice problems. Alright, let's go ahead and substitute in now. We know a is equal to 27, so we're going to say the ratio here of 27 to 75. That's going to be equal or equivalent to this ratio of x to 100. And we don't know what x is, that's going to be the percentage, so let's go ahead and leave that alone. At this point, we just have a proportion to solve. There's several different strategies you can go by here. What I'm going to do first, though, is I'm going to go ahead and simplify this ratio on the left side. I'm going to divide top and bottom both by 3. If I go ahead and do that, I'm going to see here that I think this is going to end up being, 9 over 25. So I'm going to go ahead and say the ratio of 9 to 25 is going to be equivalent to this ratio of x to 100. Now, I don't feel like using cross products here, but you can. I'm going to go ahead and just multiply, and again, use the identity property here. Multiply top and bottom both by 4 here, so that we can go ahead and find out that x is going to be equal to 36. So what was the question? It was what percent of 75 is 27? And so we can go ahead and say that 36% of 75 is 27. All right, let's try another one together. In number 2, it says what percent of 225 is 99? First, we want to identify that our unknown here is going to be x percent, or x per 100. Our part here is going to be 99. A is equal to 99 because of that word is. And then the of 225 is going to be the base here. So b is going to be equal to 225. All right, so here is our general formula we can go ahead and apply here. And so our a value is going to be 99. That's going to be 99 per what? It's 99 per 225, or out of this 225. This is basically our ratio. And this is going to be equivalent to x percent. Now, that's just going to be x over 100. Now, of course, you could go ahead and use cross products if you would like to, again, but I'm going to go ahead and divide these by a common factor that I am aware of. So I'm going to go ahead and divide top and bottom here both by 9. If you go ahead and do that, I'm going to see here that we're going to end up with 11 to 25 is equal to x to 100. And this one actually is pretty nice, just like the last one, where we can go ahead and say, well, 25 times 4 and 11 times 4 is going to be this x value. So we're going to say here that x is going to be equal to 44. So we can conclude that 44% of 225 is 99. All right, in number 3, we see that what percent of this 153 is 9 and 18 hundredths. So for the what percent, let's go ahead and say it's x percent here. And then what about the part? Well, the part is going to be a. A is going to be this 9 and 18 hundredths. Look for that word is. And then for the base here, we're going to say b is going to be equal to 153. Here is our general formula we should go ahead and practice writing. And so we can go ahead and fill in and substitute and say 9 and 18 hundredths to this 153. We can say that's going to be equal to this x over 100. Now for this one, I don't think I'm going to go ahead and use any sort of simplifying just because we have this decimal. Makes it a little bit more tricky, right? So I'm just going to go ahead and use some cross products here. So x by 153 is just going to be 153x. And then if we go ahead and just multiply our other cross products here, this is not too bad. 9 and 18 hundredths times 100 is just going to be 918. At this point, we just have a one-step equation. Let's go ahead and use the division property of equality and divide both sides by 153. And so if you go ahead and do that, I'm thinking here 918, 153. I'm thinking if I'm going to estimate here, I know 6 times 15 is 90, so I'm thinking maybe 6 times 153 would be close to this 918. So 153 times 6, it's going to be what? 18, carry the 1, 30, 31, carry the 3. Oh, this is actually going to be exactly 918. So I'm going to go ahead and put a 6 up here. That's exactly 918. We have a remainder of 0. And so we can go ahead and say that this x is going to be equal to 6. And so putting this together, we can say that 6% of 153 is 9 and 18/100ths. All right, let's check out number 4, where we have what percent of 120 is 66. All right, for the what percent, we have x percent. For the part here, we're going to have a is equal to 66. And then for a whole here, we're going to say that b is equal to 120, or a base is equal to 120. Here is our general proportion we can go ahead and set up. So let's go ahead and substitute. Our part is 66 to 120. So it looks like it's a little more than half, right? 66 to 120. That's going to be equal to x percent, or the same thing as x to 100. Okay, so we could use cross products here, but I think what we're going to do is go ahead and divide these both by 6. That's a common factor, right? I think that might be the greatest common factor. I'm not sure. I think so, though. And so if we go ahead and do that, this would end up being 11 to 20. 11 to 20, and that's equal to x to 100. Okay, so from here, let's go ahead and just use the identity property and multiply by 5 and 5 here. And we get that x is going to be equal to 55. All right, so basically what we just found is that 55% of 120 is 66. All right, let's check out questions 5 through 8, where we're going to be going ahead and using these proportions again, but this time we're going to be finding the part instead of the percentage. All right, so we're going to be looking for the part. So notice how we don't know what the number is next to the word is, and then we have a percentage of 35%, and then we have the of 80. So for the percentage, I'm just going to go ahead and write that one first like we did earlier. So it's going to be 35%. The is part, we don't know. So a is going to be equal to, and you can just leave it as a for now, or you can change it to x if you would like to use that as your unknown. Really is up to you. And then our b value here, or our base, or the whole here, is going to be 80. Okay, so the unknown is going to be a little bit different. Now, what was our formula we used from earlier? That's right, it's just a to b to x to 100. So let's go ahead and use that template here and just say here that a to b, which we know b is going to be 80, is going to be equal to, instead of saying x to 100 like we did earlier, we know it's 35%, so we can say it's 35 to 100. All right, what I'm going to do here is just divide this ratio to the right by their GCF. If we go ahead and do that, we're going to have this a to 80 is going to be equal to 7 to 20. All right, now hopefully this makes sense, but if we have 80 divided by 4, that's 20 exactly. So a divided by 4 would be 7. If a divided by 4 is 7, then that must mean that a is 7 times 4, which is 28. So we can conclude that 35% of 80 is 28. All right, let's try another one. In number 6, we have what number is 18% of 150? So we know the percentage, it's 18%. What about the part here? We don't know. It says what number is, so we don't know what that is. Let's just say a is equal to a for now. And then for our b, or our base, that's going to be 150. Here's a general formula for these proportions. Let's go ahead and substitute in here. We know a is our unknown. We're going to find the ratio of that to this 150. And that's going to be equal to this percentage of 18 per 100, or 18 out of 100 here. All right, so let's go ahead and see what we can do. We could go ahead and use cross products, but again, I prefer to simplify this if I can. So I'm going to go ahead and divide these both by 2. If we go ahead and do that, we're going to get this simplified version of a to 150, and that's going to be equal to 9 to 50. All right, so this 9 actually kind of looks like this a, so be careful. 150 divided by 3 is exactly 50, so this actually is pretty nice. If a divided by 3 is 9, then 9 times 3 would be a, so a would have to be equal to 27. And so we can say that 18% of 150 is equal to 27. All right, let's check out number 7. The question is what number is 60% of 85? Now, the percentage here is 60%. Let's go ahead and write that down. For the part, we don't know what that is, so let's just say a is equal to a for a moment. And then for our b, that's going to be equal to 85. All right, let's go ahead and substitute in where we know what we're going to have. So let's put in a to what? A to 85. This ratio should be equal to the percentage as written a ratio as well. So 60% is going to be 60 per 100. All right, now let's go ahead and see here. I think we can go ahead and just simplify this ratio on the right. We can divide these both by maybe 20. I think that's as far as we could go. Now if you go ahead and divide these both by 20 here, let's see, our simplified version is going to be a to 85, and that's going to be equal to 3 to 5. So that's a lot more simplified, and hopefully you can see here that 85 divided by something is 5, because 5 is a factor. Now 5 times 17 is 85, so I know that we can say divided by 17. So if a divided by 17 is 3, then 3 times 17 would be a, so I know 3 times 17 would be 51. So we can say that 60% of 85 would be 51. All right, for this next one here, we have what number is 82% of 215. So let's see here. Our percentage here is 82%. Let's go ahead and just write that down. It says what number is, so we don't know the part. Let's just say A is equal to A for a moment. And then for of 215, we can say B is equal to 215. Okay, so let's go ahead and fill in our formula. And so substituting in here, we can just go ahead and say the ratio of A to this 215, that's going to be equal to this 82%, which is just as a ratio 82 per 100. Now, just thinking ahead a little bit, I think we could simplify this ratio to the right. However, I don't think we can then still say what it's going to go into evenly. So for that reason, I'm just going to be thinking ahead and just go ahead and use cross products instead. So A times 100 is just going to be 100A. So a coefficient of 100 is not too bad, because when we divide by 100 later, we can just slide the decimal over a couple spots. So the only kind of real extra bit of calculations we have to do is this 215 times 82. So let's go ahead and do that. 215, 82. Just go ahead and line those up by place values and then multiply. And so it looks like we're getting here 17,630. Okay, so pretty big number here, but if we just go ahead and divide both sides by 100 using the division property of equality, we can really just slide over that decimal twice to the left here. So A would be equal to, what is that, 176 and 3/10. So we can say that 82% of 215 is 176 and 3/10. All right, let's switch up a little bit and check out numbers 9 through 12. This time we're going to be finding the base instead in these proportions. So let's check out number 9 here, where we have 81 is 54% of what number? So identifying the different parts of this problem, we have 54% as our percentage. Our part here, just on a little bit different from the last ones, we actually know the part is going to be 81 because it says 81 is, and in this time we don't know the of, it says of what number, so we can say B is just equal to B. All right, here is our proportion that we're going to be filling in here, so let's go ahead and do that. We have this ratio of 81 to this unknown of B for now, right? And that's going to be equal to 54 per 100, because percentages are per 100. Okay, let's see if we can simplify this ratio to the right. Would it be helpful? I think it might be. Let's go ahead and divide these both by 2 over here. If we go ahead and do that, we're going to see that it's going to be 81 to B is going to be equal to 27 to 50. All right, now the reason why I think this one is still going to be useful is because it turns out 81 divided by 3 is 27, and then so B divided by 3 would be 50. And so if that's true, then 50 times 3 would be B, so we can say that B here would be equal to 150. So we can say that 81 is 54% of 150. All right, let's check out number 10. Here we have 42 is 200% of what number? So this is our first time having a percentage over 100%. Hopefully you can kind of think about what might be different in this particular case. But our percentage here nonetheless is going to be 200%. Our part here, it says 42 is, so it's going to say A is equal to 42. And it says of what number? So for that B value, we don't know what that is. We can say B is equal to B for now. All right, here is our proportion that we're going to go ahead and fill in. So let's say we have 42 to B. And that's going to be equal to this ratio of 200%. Now that's just 200 per 100, right? So percentages are always going to be out of that 100. Now this one's really nice to go ahead and simplify. We can actually just divide this top and bottom by 100. And it's actually quite more straightforward than some of the other ones here. So if we simplify, we're going to have 42 to B is really the same thing as a 2-to-1 ratio here. And so this is nice because we can say, well, 42 divided by 21 is equal to 2, because 2 times 21 is 42. So B divided by 21 is equal to 1. Now if that's true, that means that 1 times 21 is equal to B. So B must be equal to 21. And so we can say here that 42 is 200% of 21. And hopefully that makes sense because 100% of this 21 would just be 21. So 200% of 21 would just be doubling it. And that's where the 42 comes from. All right, number 11, we have 7 is 28% of what number? Our percentage here is 28%. Our part here we can just say is going to be A is equal to 7. And then for our base or our whole here, we can say that B is going to be equal to B. All right, here's our general proportion. We can go ahead and substitute in here and say that the ratio of 7 to B, let's say that is going to be equal to 28 to 100. Now this one's really nice compared to a lot of the ones we've done. Hopefully you can see here that we can actually just say that if 7 times 4 is equal to 28, that means B times 4 or 4B is equal to 100, right? So we can actually just go ahead and say here that if B times 4 is 100, we can actually just write it as a one-step equation and say 4B is equal to 100. And if you go ahead and divide both sides by 4 using that division property of equality, we can say here that B would be equal to 25. And so we can say here that 7 is 28% of 25. All right, let's check out another one here. In number 12, we have 71 and 5/10 is 252% of what number? Our percentage here is going to be 252%. Our part here is going to be this 71 and 5/10. And then our base or whole here is going to be unknown. So let's leave that alone. All right, so we have 3 of our pieces here. Let's go ahead and substitute them in. We have 71 and 5/10. That's going to be our part. Our whole here or our base is unknown. That's going to be our B value. And this is going to be equal to what? Our percentage is going to be 252%. That's 252 per 100. Now, like I kind of said earlier with these decimals, I think what I generally just like doing is using cross products in these cases unless I can see a pattern that we could maybe simplify nicely. So if we go ahead and multiply here using cross products, 252 times B is 252B. And then for our other cross product, this really isn't bad, multiplying this decimal by 100. I don't think you need to write any calculations out here, but slide the decimal twice to the right when you make it 100 times bigger. That's going to be 7150. Okay, so 7,150. Now we just have a one-step equation here. We can divide both sides by 252 using that division property of equality. And then now here we really do have one calculation to make, which is this division. Now, because this one doesn't come out to a very nice number, feel free to go ahead and use a calculator for this division problem. You're going to find out it should be about 28 and 37 hundredths. So I'm going to actually go ahead and change this equal sign to an approximation symbol, and you should too here, and say B would be approximately 28 and 37 hundredths. And so we can say that 71 and 5/10 is about 252% of 28 and 37 hundredths. This one's not exact, but it is a pretty good approximation here. All right, let's try one application problem together. In number 13, let's go ahead and apply what we've been practicing here. This time, I'm not really going to be telling you if we're looking for a part or a whole or a percentage. We're just going to see if we can figure out which one it is and then apply it to the situation that we have. So basically, we have 2 different stores selling the same bike, but maybe for some different prices. All right, so let's look at this first store. At Lope's store, the bicycle is on sale for 20% off the original price of $240. How much money will Aristo save by purchasing the bicycle on sale at Lope's store? So while there's definitely different ways you can go about solving this, we're really practicing using proportions here. So let's go ahead and set this up as a percentage here. I think we're going to say here that we don't know the discount. Let's go ahead and say that's going to be A. Our unknown is going to be part of what the whole price is. The whole price of this bike is $240, so that's going to be the base here. And 20% off means it's a 20%, it's 20 out of 100. So if we go ahead and simplify this, we can say that A to 240, that would be equal to, and if you simplify 20 to 100, that's really a 1 to 5 ratio, right? You get to save 1/5 of the price with this 20% discount. Now, 5 times what is 240? If you want to go ahead and think about how many times that would go in, it goes in quite nicely here, right? Because it's a multiple of 5. So I think it's going to be 48. So you go ahead and write divide by 48 divided by 48. Feel free to do some side multiplication, but I think that one I can do okay there. And so if A divided by 48 is 1, then 1 times 48 would be A. So I know at this point, or we know at this point, hopefully, that A would be equal to 48. That would be the discount here. So we can say that Aristo would save $48 if he bought this bike at Lope's store. All right, let's check out part B. What if Aristo went to Owen's store? What would happen here? Well, the bicycle's on sale for 25% off the original price of $265. The question is, how much money will Aristo save by purchasing the bicycle on sale at Owen's store? Well, let's see. Kind of similar to the last one here. We don't know the discount. We're looking for that discount, which is part of the entire price of $265. That's our base. But we know that it's a 25% discount. So we're going to set this up originally as 25 per 100. All right, so this ratio on the right simplifies quite nicely. So we have A to 265 is equal to this 1 to 4 ratio. So basically he's going to save 1/4 of the price. I don't think this is going to go in nicely no matter what we really kind of do here. So I'm going to use cross products here and say that A times 4, that's going to be 4A. And then 1 times 265 is just 265. Let's go ahead and just use the division property of equality and divide both sides by 4. We know this isn't going to go in nicely, but that's okay. We're going to say A is going to be equal to, and let's go ahead and just do some long division on the side here. So we're going to say that A here is going to be 66 1/4. If you really want to go ahead and say what this is in terms of money though, feel free to go ahead and add a decimal and bring it down. Or if you know that 1/4 is just 25 cents, then you don't have to really do this. You can just go ahead and write that down. But if you want to go ahead and see what that looks like to get the decimal value, then you can go ahead and just keep doing the division here and it'll work out nicely as well. So this one's not too bad though. So it's $66.25. And so at Owen's store, Aristo would save $66.25 on this bike. All right, so we know what the savings would be at each of these stores. Let's go ahead and see for part C. It says, which bicycle should Aristo buy? It says, go ahead and justify your answer with mathematical reasoning, work, and an explanation. All right, so first of all, at Lope's store, we know the original bike cost is going to be $240. But if we're going to go ahead and be saving $48 with that discount, what is he actually going to end up be paying? Well, if you go ahead and subtract here, that's going to end up being $196 for that bike. At Owen's store, we knew the original price was $265. The discount we found out was going to be $66.25. So it was more expensive, but the discount was also a higher percentage and a greater amount of money. Let's see if this comes out to being more or less. Well, if you go ahead and subtract here, you can go ahead and do that on the side if you need to. That's going to be a total of this $198.75. And so if we go ahead and use all the information that we just found, I think it's fair to say that since $196 is less than $198.75, that Aristo should go ahead and buy this bike at Lope's store because he's going to save a little bit of money here. So there you have 13 different practice problems on solving these percent problems, specifically using this method of using proportions. There are some other strategies we'll talk about in some future videos, so if you're looking for some different methods, then stay tuned to check some of those out. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.